Hey everyone, welcome to this explainer. I am so incredibly excited to have you here today. If you're prepping for your grade 8 technology exam set by the Department of Ed, well, you're in the exact right place. Today, we're diving into two of the absolutely coolest mechanisms in engineering, cams and cranks. My goal, to make these mechanical concepts so incredibly simple, literally so clear that a 5-year-old could totally grasp them. We're going to break it all down step by step, and by the end, you'll be more than ready to just crush those exam questions. Okay, let's dive into our roadmap really quick. We'll start with the magic of motion, then jump right into what a cam is and how it moves things. After that, we'll look at our second mechanism, the crank, compare the two side by side, and finally, test your brand new machine knowledge with a quick activity. Let's get to it. Section 1. The magic of motion, how things move in our world. Machines don't really speak English or Spanish, right? They speak the language of motion, but they only have a few languages to choose from. So sometimes engineers have to figure out how to translate one type of movement into a completely different one. There are 4 main types of motion, but for your exam today, we're going to focus purely on 2. First up is rotary motion. That simply means spinning in a circle. Think of a bicycle wheel or a ceiling fan. The second one is reciprocating motion. Think of the word reciprocate. It basically means going back and forth or bouncing up and down in a perfectly straight line, kind of like the needle on a sewing machine. And that brings us to the ultimate engineering problem. How do we turn a spin into a bounce? Just imagine, you have the motor that only spins in a circle, but your toy, or maybe the machine you're building, needs a specific part to move straight up and straight down. How on earth do we force a spinning circle to create a straight, bouncing line? Section 2. What is a cam? Our first magic translator. Well, this is exactly where engineers step in with a brilliant, yet honestly incredibly simple solution to our spinning to bouncing problem. The textbook definition you need to know is this. A cam is a mechanism that changes rotary motion, which is spinning, into reciprocating motion, up and down, using an oval-shaped disc. But let's put that in 5-year-old terms, right? A cam is basically just an egg-shaped wheel. That's really it. It's just a wheel that isn't perfectly round, and as it spins, that weird, lopsided egg shape literally pushes things out of its way. Now, what's really interesting here is how this answers our first big exam question. What moves? The egg-shaped disc at the bottom, that's the cam itself, and it has rotary motion. It just spins. But resting right on top of it is a straight rod. We actually call that the follower because, well, it literally just follows whatever the cam does. Because it's trapped in a vertical guide, that follower rod has reciprocating motion, meaning it goes up and down. Section 3. How cams move things. Step-by-step movement. All right, so now that we know what parts move, let's build the scaffolding for your exam and explain exactly how it happens. It's basically a simple 4-step story. Step 1, a motor or handle turns the central axle, which forces our oval cam to spin. Step 2, our straight follower rod is just resting lazily right on top of that spinning oval. Step 3, because the oval is totally uneven, its long, pointy end eventually swings around and shoves the follower rod straight up into the air. And finally, step 4, as the cam just keeps on spinning, the flatter side of the oval comes back around and the rod drops right back down. So it's just spin, push up, drop down, spin, push up, drop down. And this brilliantly illustrates the absolutely crucial why of the whole mechanism. It's all about the shape. The stretched out part of the egg shape is what we call the high point. When that high point rotates all the way up to the top, it physically takes up more space, so the follower rod has absolutely no choice but to be pushed upward. Then you have the low point. When that flat side rotates to the top, the space opens up again, and gravity just pulls the follower right back down. It's really just a game of taking up space. Section 4. What is a crank? The second magic translator. Now, engineers are pretty smart, and they know there's always more than one way to solve a problem. If we don't want to use an egg-shaped cam, well, we can use a crank. This mechanism might look a tiny bit more complicated with connecting rods and pistons, but I promise you, you already know exactly how this works. Just think about riding a bicycle. Your leg is pushing a pedal around and around in a big circle, right? That pedal is a crank. It's basically an arm attached to a spinning center that takes your up and down leg movement and turns it into spinning wheel movement. Or it can work in reverse. It takes a spinning movement and turns it into an up and down or back and forth movement. So let's answer what moves for the crank. There are 4 main characters in this story. First, you have the main shaft right in the center, spinning in a continuous circle. Second, there's the crank arm. The real secret here is that this arm is attached off-center. As the main shaft spins, the far end of that arm sweeps out in a massive circle. Third, attached to the end of that sweeping arm, we have the connecting rod. And finally, the piston. Because the connecting rod is being violently dragged in a circle at one end by the arm, it forcefully yanks and shoves the piston back and forth in a straight line at the other end. Section 5, cam versus crank comparison. Which one is better? Let's pause and see how this builds. If they both do the exact same job, turning a spin into a straight line, how do you choose which one to use? Honestly, it all comes down to power versus timing. A cam is really just an oval disc bumping a rod up and letting it fall. It relies purely on gravity to drop the rod back down. Because of this, cams are for light, delicate tasks. They're totally perfect for tapping out notes in a musical box or, making a little wooden bird pop out of a cuckoo clock at exactly the right second. But a crank? A crank uses a solid attached arm to physically pull and push a rod. It has incredible power. That's exactly why we use cranks for heavy-duty tasks, where massive force is needed, like driving the pistons in a roaring car engine or powering the pedals on your mountain bike. Section 6. Test your machine knowledge. Exam prep activity. So the crucial point here is taking everything we just talked about and proving you can actually use it. It's time to put on your engineering hats. I'm going to show you 2 diagrams straight out of your study materials, and I want you to identify which one is the cam and which one is the crank. I'll give you a second. Okay, looking at the first one. Do you see an arm firmly pulling a rod, or do you see an egg shape just pushing a stick? That's right, that one is the cam. The rotary motion of the oval perfectly translates into the up and down reciprocating motion of the follower. Now the other one. We see an arm spinning in a circle, securely attached to a connecting rod, actively shoving a box back and forth. That is definitely our heavy-duty crank. Now, for your absolute final exam challenge. Right now, wherever you are, I actually want you to try and answer these 3 questions out loud for both the cam and the crank. What moves? How does it move? And why does it move? If you can confidently talk through the spinning egg, pushing the follower, and then the sweeping arm dragging the piston, then you are absolutely 100% ready for your exam. Before you go, take a quick look around your house today. What other everyday objects might be hiding these magical translators inside? Is there a crank hiding in your kitchen somewhere? Maybe a cam hiding in your washing machine? Keep your eyes peeled, stay incredibly curious, and hey, good luck on your test. You've got this.